When you touch something, what exactly is happening? Have you ever thought about it? In a macro point of view, you might say that you're exerting a force upon an object that you're touching. This is correct, but what is this force, and what causes it? To answer this question briefly, this is a phenomenon of electromagnetism. That's cool, Riley. What the hell is that? Simply, it's the force that acts on electrically charged particles. Similar to how gravity is a force that acts on all things massive, electromagnetism is a force that acts on all things electric. Unlike gravity, however, electromagnetism can either attract or repel. I'm sure you've experienced something like this before. Well, touch is a direct result of this, but what I mean is if you play with magnets enough, you will notice that when you put two of the same sides together, that they repel. You will also notice that just the opposite happens when you do the opposite. You can think of electrically charged particles like sides of a magnet. For a negatively charged particle, for example, an electron, you can think of them like the south side of a magnet. When two of them are brought together, they repel. When you introduce a north-sided particle, like the proton, to a south-sided electron, they are attracted to each other. This is called the electrostatic force. However, instead of saying north and south-sided particles, we say that the particle is either positive or negatively charged. This repulsion and attraction of charges actually results in almost all of the physical phenomenon we experience daily. Now back to touch. If we zoom in on your hand and the object that you're touching, we can see the atoms that build the border between your hand and the object. Within the atoms, we see a nucleus of protons and neutrons, and around them, electrons fly about. The electrons in the opposing borders between your hand and the object that you're touching then repel each other just like two south sides of a magnet. This repulsion is exactly what you feel as touch. For those who might come across this problem, the reason we don't always feel this repulsion is because we actually do. At great distances, however, the force of repulsion of the electrons in you and whatever object is in question almost completely matches the force of attraction of the electrons in you and the protons in the object, and vice versa. You can easily see this on a qualitative model I made on Desmos. When two objects are far apart, in this case two atoms representing the imaginary borders of said objects, the force of attraction and the force of repulsion are almost equal. At a distance of a centimeter, for example, almost equal pretty much means it is equal. The difference between the attraction and repulsion at this distance is so small that it doesn't matter. When we bring the borders, and thus the electrons closer, the force of repulsion felt by the electrons becomes exponentially greater than the force of attraction felt by them. This results in what we perceive as touch. In this video, you learned that, just like magnets, opposite charges attract and same charges repel. This is called the electrostatic force, but it is part of something much bigger called electromagnetism. You also learned that this results in what we perceive as touch.